Before switching to the laptop screen, I will first explain the basic definitions and types of regression analysis used in research methodology. Imagine you are trying to find a connection between two things. For example, does the number of study hours affect a student's exam marks? This is where regression analysis helps. Regression analysis is a way to study the relationship between one main thing you want to predict, called the dependent variable, and one or more things that might affect it, called independent variables. So, in our example, exam marks equals dependent variable, what we are predicting. Study hours equals independent variable, what we think causes the change. Regression gives us an equation or a line that shows how much change in one thing leads to change in the other. Now let's talk about types of regression in research. Simple linear regression. Simple linear regression is used when we study the relationship between one independent variable and one dependent variable. Example, does the number of study hours affect exam marks? Here, study hours equals independent variable, exam marks equals dependent variable. We are using one factor, study hours, to predict another, marks. Multiple linear regression. Multiple linear regression is used when there are two or more independent variables and one dependent variable. Example, how do study hours, sleep hours, and class attendance affect exam marks? Here, independent variables equals study hours, sleep hours, attendance, dependent variable equals exam marks. This type helps us see which factor is more important in predicting results. Logistic regression. Logistic regression is used when the result is not a number but a category, like yes or no or pass or fail. Example, will a student pass the exam, yes or no, based on their study hours? Instead of a score, we are predicting a yes or no outcome. Polynomial regression. Polynomial regression is used when the relationship between the variables is not a straight line but a curve. Example, how does age affect memory power? At first memory improves, but later it may decrease. This creates a curve, not a straight line. Ridge regression. Ridge regression is used when there is too much data or too many variables, and we want to avoid overfitting, making the model too perfect for just one dataset. Example, predicting house prices using 50 features like size, location, number of rooms, nearby schools, etc. Ridge helps control and simplify the model when the data is too complex. Lasso regression. Lasso regression is similar to ridge, but it can also remove unimportant variables from the model. Example, out of 30 factors that affect salary, Lasso might find only 5 that really matter and remove the rest. This makes the model simpler and easier to understand. So, how do we know when to use regression in a study? Here are a few signs. You want to predict something, like sales, grades, income. You want to check if 2 or more things are related. You want to understand which variable is most important in affecting outcome. Examples, in education, does attending tuition improve marks? In health, does smoking lead to heart problems? In business, do ads increase product sales? Today, we'll focus on simple and multiple linear regression, since these are most common in theses and journal articles. Make sure the data analysis tool is enabled in Excel. To do this, follow these steps. Go to File Options, click on Add-ins. In the Manage box at the bottom, select Excel Add-ins and click Go. Check the box for Analysis ToolPak and click OK. Once enabled, go to the Data tab in the ribbon. You will find the Data Analysis option on the far right side. Let's say we are studying how students' study hours and sleep hours affect their exam scores. Here's a small dataset that we'll use, dependent variable, y. This is the thing we want to predict. In this case, it's the exam score. Independent variables, x. These are the factors that might affect the exam score. For simple linear regression, we will use only study hours. For multiple linear regression, we will use study hours and sleep hours together. Let's start with simple linear regression in Excel. Click on the Data tab in the Excel menu. On the right, click Data Analysis. In the regression box, input y range, select the dependent variable, exam scores, input x range. Select the independent variable, study hours. Remember, we are performing simple linear regression, so we are selecting only one independent variable. You don't need to write other independent variables in simple linear regression. Only one independent variable is needed for simple linear regression. It is just an example where I am showing how you can perform different types of regression analysis. Check the box for labels, output range, choose any empty cell, like F1, click OK. You will get the results. Now let's see how to interpret these results. Part 1, Regression Statistics, multiple R equals 0.99. This shows a strong relationship between study hours and exam scores. Closer to 1 means a strong connection, and 0.99 is almost perfect. R square equals 0.98. This means 98% of the changes in exam scores can be explained by study hours. So, study hours really do affect the scores in this case. Part 2, ANOVA table, significance F equals 0.000056, or 5.6E05. This number is very small, less than 0.05, which means the regression is statistically significant. In simple words, study hours truly impact exam scores, not just by chance. Part 3, Coefficients. Let's understand the formula Excel gave us. Intercept equals 41.71. If a student studies 0 hours, the predicted score is about 41.7 marks. Study hours coefficient equals 6.28. For every extra 1 hour of study, the exam score goes up by 6.28 marks. So, if a student studies 5 hours, predicted score equals 41.71. 6.28 by 5 equals 73.11. Now let's do multiple linear regression. Now we'll use both study hours and sleep hours to predict exam scores. Again, click Data Analysis Regression OK. Input Y range, exam scores, input X range, both study and sleep hours, check labels, output range, select any blank area, click OK. Now let's look at how to understand the results of multiple linear regression. We're checking how study hours and sleep hours together affect exam scores. Part 1. Regression statistics, multiple R equals 0.996. This shows a very strong connection between the two predictors, study sleep hours, and exam scores. R square equals 0.993. This means 99.3% of the changes in exam scores are explained by study hours and sleep hours together. This is an excellent model. Part 2, ANOVA table, significance F equals 0.00049. This number is less than 0.05, which means our model is statistically significant. So, yes, study and sleep really do affect scores, not just by luck. Part 3, Coefficients. Intercept equals 34.45. If a student studies 0 hours and sleeps 0 hours, which isn't realistic, the base predicted score would be 34.45. Study hours coefficient equals 6.22. For every 1 extra study hour, the score increases by about 6.22 marks. Sleep hours coefficient equals 1.13. For every 1 extra hour of sleep, the score increases by about 1.13 marks, but the p-value here is 0.18, which is more than 0.05, so sleep isn't a strong predictor in this small dataset. Study hours strongly affect exam scores. P-value is very small. Sleep hours have a small effect, but not statistically strong in this case. You've just learned how to find, read, and explain a simple linear and multiple regression analysis in Excel. Ask any questions in comment sections. If this video helped you, please give it a thumbs up, subscribe to the channel, and hit the bell icon so you never miss future videos on research, statistics, and data analysis.